Hello again, Precalc friends. We're getting near the end of Chapter 7. This is Precalculus, Section 7.5, Day 1 Notes. Today we are going to begin talking about solving trigonometric equations. So the first thing I want you to pay attention to is the fact that the instructions for example 1 say to find all solutions of the equation on the interval 0 to 2 pi. So what that's asking us to do is find the solutions of this equation that live just in one pass around the unit circle. Because remember, we could keep going around and around and around, and we could have an infinite number of solutions for any equation because cosine is a continuous function that just keeps going. It's periodic. And the same thing with sine. So if we restrict our interval and we say just 0 to 2 pi, then that means that we're just looking for answers that live on one revolution of the unit circle. But before we get to that point, first we need to solve our equation for cosine x. So just like any other algebraic equation, the first thing I'm going to do is add 1 to both sides. And then I'm going to divide by 2. So I end up with cosine x equals 1/2. So now again, you kind of have to put your thinking cap on and ask yourself, well, where on the unit circle is my cosine value 1/2? Or where is the x value of my ordered pair 1/2? So if this is my unit circle, I know that that's going to occur in two locations. It's going to occur in the first quadrant at pi over 3, and it's going to occur in the fourth quadrant at 5 pi over 3. Those are the two locations where my ordered pair has a 1/2, and then this is square root of 3 over 2. This one is 1/2 negative square root of 3 over 2. But what we care about is the fact that the x value, or the cosine value, is equal to 1/2. So my two solutions here for this problem are x equals pi over 3 and x equals 5 pi over 3. All right, let's look at number 2. Example number 2, we've got tangent squared x minus 1 equals 0. So again, we're just going to do some algebra. We're going to add 1 to both sides. So then we have tangent squared x equals 1. And then if we want to undo something that is squared, we have to square root it. So we end up with tangent of x equals, remember when we square root, we get two answers, right? So we get plus or minus 1. So the next question becomes, where does tangent equal 1? Okay, or negative 1. That's going to occur at 4 locations on the unit circle. Tangent is positive 1 at pi over 4 and at 5 pi over 4. And tangent is going to be negative 1 at 3 pi over 4 and at 7 pi over 4. So this time I am going to have 4 answers, right? Let me write these down for you. 1 pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So the answer to my problem here is all 4 of those, because again, we're looking at where does tangent equal either positive 1 or negative 1 on one revolution of our unit circle. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay. Next example, we want to find all solutions of this equation. Okay, now, all solutions means that we have to account for the fact that we could keep going around the unit circle to infinity. Okay, so here's my little note. Sine is periodic. So our solutions keep repeating on intervals of 2 pi. So what that means for us is once we figure out what our answer is, after our answer, we're going to have to add plus 2k pi, which means we keep going around the circle, we keep adding more answers. So if we add 2 to solve this, then we have cosecant of x equals 2. Well, cosecant is the reciprocal of sine. So if cosecant of x equals 2, then that means that sine of x would be the reciprocal of 2, which is 1/2. Okay, so first question, where does our sine value equal positive 1/2 on the unit circle? That's going to have to be in quadrants 1 and 2 that happens. And that happens at pi over 6 and at 5 pi over 6. Okay, but because we're saying that we want all solutions, then we have to write our answer as x equals pi over 6 plus 2k pi, which means every time you go around this unit circle, you get another answer at that location, and 5 pi over 6 plus 2k pi, which means every time you go around the unit circle, you get another answer at that location. All right, now we get to something slightly more complicated. If you notice, this equation kind of looks like a trinomial. It's similar to 2u squared minus 7u plus 3 equals 0. So basically, this is going to become a factoring problem. You can factor this any way you want. You can do the JSteele steps. You can do the Miller magic, also called slide and divide. You can do grouping, whatever you want. My preference is to do it quickly, right? So I know that this is going to factor into 2u times u because I start with 2u squared. And I know if I've got that 3 that I'm going to end up with a positive 1 and a 3 here because I need to make a negative 7 in the middle. So I want the 2 times the 3 to make 6 and 1 times u to make u. So that factored up pretty quick. So now that I've got it factored, I'm going to go ahead and I'm going to replace cosine x with my u. So I've got two equations that I still have to solve. I've got 2 cos x minus 1 equals 0 when I set it equal to 0. And I've got cosine x minus 3 equals 0. So now I just have to do the math. So here I am going to add 1 to both sides. So I have 2 cos x equals 1. Divide by 2, and I get cosine x equals 1/2. My other equation, I add 3 to both sides, and I get cosine x equals 3. Hopefully that's kind of drawing a red flag to your attention here. This one's going to give us no solutions, right? Because remember what we said earlier? Cosine can never be greater than 1, and sine can never be greater than 1. So that one's going to be a no solution. But cosine of x equals 1/2 is going to have 2 solutions because that occurs in 2 locations on the unit circle. Cosine is positive in quadrants 1 and 4, and cosine is 1/2 at pi over 3 and at 5 pi over 3. Those are the 2 locations where cosine of x is equal to 1/2. So my answer here is going to be x equals pi over 3 plus 2k pi, and x equals 5 pi over 3 plus 2k pi. And this coordinate plane over here would have been for my other equation, but since cosine of x was equal to 3, that's going to be no solution. All right, this next equation is interesting yet again. Notice that we have 2 terms, and both of our terms contain sine x. So let's begin by taking out a GCF of sine x. So if we factor out a sine x, then what we have left in the first term would be tangent x, and what we have left in the second term would just be 1. So now we have two equations to solve. We have sine x equals 0, and we have tangent x equals 1 when I move that 1 over to the other side. So where does sine of x equal 0? Well, that happens at two of our anchor points, right? On our unit circle, sine, or our y value, is 0 at 0 and at pi. Okay, so here we could say x equals 0 plus 2k pi, and x equals pi plus 2k pi. Okay, but notice that these are only pi apart, right? 0 and pi. So we only need to use one of these solutions, because if you add pi to one of the solutions, you're going to get the other solutions. Okay, so really we would call this condensing the solution. So we can condense this solution and we can say x is really equal to 0 plus k pi, because at every interval of pi we have a solution, right? We have a solution at 0 pi, at 1 pi, at 2 pi, at 3 pi, at 4 pi, so on and so forth. The second part of the problem here is where tangent x equals 1. We know that that tangent is positive in quadrants 1 and 3, and we know that tangent equals 1 at our pi over 4 locations. So this is going to happen at pi over 4 and at 5 pi over 4 on the unit circle. But just like before, if we say our solutions are x equals pi over 4 plus 2k pi and x equals 5 pi over 4 plus 2k pi, it's not that that's incorrect, it's just that it's kind of overkill, because we again only need to use one of these solutions. If you add pi to one solution, you get the other solution, right? If you're at pi over 4 and you add pi to it, you'll be at 5 pi over 4. So we can condense our solution down, and we can just write this solution as x equals pi over 4 plus k pi. So if we need all of our solutions, our two solutions are going to be x equals 0 plus k pi and pi over 4 plus k pi.